Hello class, the title of this lesson is Solving Absolute Value Equations. Our learning target is I can solve an absolute value equation. So we'll get right into the rules. On our first page here, we can see we need to talk about the steps of how we solve an absolute value equation. So step one says we are going to have to isolate the absolute value bars. And we need a quick reminder of what those bars look like. They're two vertical bars that may be around an x or some sort of algebraic expression. So these bars here are called absolute value bars. And to isolate means to get the portion of the problem that's in those bars all alone. The second step is going to be to make two problems. When we're making two problems for our first problem, we are going to keep all the signs as they are. And for our second problem, we have to change signs of just one side in the second problem. We'll look at how that works in an example. Another thing I need you to know is when we see an equal sign in absolute value equations, we're going to divide the two problems with the word or. Now, we're going to be leading up to inequalities. We're not doing inequalities today, but notice that sometimes we're going to get the word or and sometimes we're going to get the word and. With equations, we're going to deal with the word or. Okay, step 3, we're just going to go ahead and solve both problems. Step 4, we have to check solutions. And sometimes I know in algebra you don't really want to check your answer after you get the answer, but you're going to have to check your answer here, and we'll talk about the reason when we get to it. And then last, we're going to write our answer in some sort of special notation. Sometimes we'll graph them, but for today, we're going to put our answers in set builder notation. So let's look at our first example. Absolute value of x minus 25 is equal to 17. Let's go back to our steps. Step 1, we need to isolate the absolute value bars. Well, looking here, I noticed that there are no other terms on the left-hand side of the equation that are not contained in the bars. So I would say that these bars are already isolated. So we're ready for step 2. Sorry, not problem 2, step 2. Step 2 says to make two problems. So when we make our two problems, for our first problem, we're just going to drop the bars and write exactly what we see. X minus 25 is equal to 17. We're going to separate with the word or when we're dealing with equations. And the second problem is really where we see some differences. So for the second problem, we're going to keep the expression x minus 25, keep the equal sign, but anything that comes after the equal sign is going to get a sign change. Is equal to negative 17. So there's our two problems. First problem, we just drop the bars and bring everything down. Second problem, we change the signs that come after the equal sign. So next I'm going to add 25 to both sides here to get the x alone. So plus 25. And so I'm going to get x equals, let's see, 17 plus 25, 42. So x is equal to 42. And then we're going to solve the other one. Add 25 to both sides. So that's going to cancel. And negative 17 plus 25 signs are different. So we actually subtract the numbers, take the sign of the larger one, which is positive. That is 8. Positive 8. So these are the two solutions that we get. X is equal to 42 or x is equal to 8. Now, let's refer back to our steps. We made two problems. We divided with the word or. You know what? We have already solved. So we've already been through step 3. We solved both problems. Now, step 4 is to check your solutions. The checking process is not a process that you can skip when you're dealing with absolute value. What we have to do is consider, if I take this 42 and I substitute it right here in place of that x in my original problem, do I still get positive 17 for the answer? So we can substitute by checking on the calculator, and if you'll pause now, Mrs. Moon will show you how you can substitute into the calculator and check your answer with your calculator without having to write it down. So pause for a moment. All right, so if we check this, we know that 42 minus 25 is 17, and the absolute value of 17 is 17. If that creates a true equation, then we will say that that answer choice is a true answer or is a true solution to this equation. We also have to check with the 8. So in that case, we would substitute an 8 in for x, and the absolute value of 8 minus 25 would actually be negative 17, but the absolute value of negative 17 is 17. Therefore, we still get 17 equals 17. Both solutions are correct, so we get 2 answers here. The last step said to write the solution in set builder notation. So we're going to create our fancy curly bracket, and we'll say all x's such that x equals 42 and also 8. 42 or 8. We separate multiple answers with a comma. Okay, let's take a look at example 2 together. Again, our first step when we're solving an absolute value equation is to isolate the absolute value portion. So in this problem, we should see that we've got this number negative 2 that is being multiplied by the absolute value expression. So in order to isolate the absolute value expression, we're going to have to divide by negative 2. And what I do on one side, I'm going to do on the other side. So when I divide, negative 2 divided by negative 2 is going to cancel or divide to be 1. I'm rewriting this as the absolute value of 3x plus 4 is equal to 6 divided by negative 2, negative 3. So I've got the absolute value of some expression is equal to negative 3. Now the second step for solving an absolute value equation would be to create 2 problems. So if I'm going to follow through my steps, this would be my next step. 3x plus 4 is equal to negative 3, or 3x plus 4 is equal to, change the signs after the equal sign, positive 3. And then I will go through the steps to solve each of these, and then I will check each solution. And after I check each solution, I will write in set builder notation the correct solution. But I will tell you now that I'm going to save us some time. I can go through all these steps to solve this equation. I can go through all the steps to solve this equation. And I'll get 2 answers. And then if I go back and check those answers in my original problem here, check them here, then I'm going to find that neither answer is going to work. Let me tell you how I know that. When we are finding the absolute value of something, then this absolute value is going to take whatever this expression 3x plus 4 is, whether it be positive or negative, it's going to make that answer, take that answer and make it positive, because absolute value, remember, is measuring a distance, and distances are always positive. So I should get, when I have absolute value bars all alone, it has to be equal to a positive number. This is showing absolute value equal to a negative. This is what I like to call a red flag situation. When you isolate absolute value and you see that it's equal to a negative number, that's a red flag, because absolute value is always going to equal a positive number. So when I see this situation, I could go on and do the work, or I could recognize it and save myself the time. If I recognize it, I can just say, oh, this is going to be a no solution answer. No solution, or the empty set. Neither answer that I find is going to actually work. In example 3, again, step 1 is to isolate the absolute value expression. I see that there is a plus 5, so I'm going to use the additive inverse. and I'm going to subtract 5 from both sides. So I've got the absolute value of 2x plus 7, now isolated, equal to negative 5. Ooh, what do we notice? Again, we're seeing, if you recognize it here, you save yourselves a lot of work. We're seeing that we've got absolute value equal to a negative. Absolute value, by definition, is always going to equal a positive number because it's a distance. So anytime you have absolute value alone, that's all that's on this side, and it shows equal to a negative, that's your red flag situation, and you're going to say from here, there is no solution, the empty set. In the next example, again, we need to start by isolating absolute value. We've got 8 being multiplied by this absolute value expression. So I begin with division. I divide by 8 on both sides. That gives me the absolute value of x minus 3 is equal to 11. There's no red flag this time. I've got absolute value equal to a positive number. That's acceptable. So then I move on through my steps. After I've isolated, I'm ready to write 2 problems. So my first problem will be x minus 3 equals 11. Or the second problem will be x minus 3 is equal to negative 11. Take a moment to solve each of these. And we find that x is equal to 14, or x is equal to negative 8. After we solve, the next step is to check your solutions. Make sure that those solutions actually work in the original problem. So we go back to the original problem, and we're going to replace x with 14. So if I follow order of operations here, 14 minus 3 is 11. So I get the absolute value of 11 times 8, and that would be 8 times 11, which is going to equal 88. So 14 is an acceptable answer. Give it a check mark. And last, we want to check negative 8 as a possible solution. You see, in absolute value, the solutions you find are just possible solutions until you check them. So we're going to check negative 8 as a solution. So if we substitute in negative 8 minus 3, that's going to be negative 11 multiplied by 8. Absolute value of negative 11 is 11, so 8 times 11 again is going to be 88. So I will say check mark, yes, that is also an answer. So in set builder notation, my solution will read x such that x equals 14 or negative 8. Or we could write it this way. X such that x equals 14, comma, negative 8. Example 5 gets quite a bit more tricky. If we follow through our steps, step 1 is to isolate absolute value. Look at your absolute value. There's nothing else on this left side of the equal sign other than what is contained within the absolute value. So that step is already complete. Absolute value is isolated. Step 2 is make 2 problems. First problem, x minus 2 just comes down, equals 2x minus 10 just comes down. For the second problem, we're going to keep what's in the absolute value bars the same. And we're going to change the signs after the equal sign to be negative 2x plus 10. So all of the signs on one side have to be changed. It doesn't technically matter which side you change the signs on, but I always change the signs after the equal sign. Now we're going to solve each of these. So I notice here I've got an x on both sides. I don't like that. So I'm going to pick one to eliminate. I'm going to subtract x from both sides. So that cancels. It leaves me with negative 2 equals 1x minus 10. And then I'm going to add a 10 to both sides. So x then equals 8. That is a possible solution to this equation. On the other one, I see I have an x on both sides. I'm going to eliminate negative 2x by adding 2x. Okay, and 1x and 2x adds to be 3x minus 2 equals 10. And I'm going to add a 2 on both sides to try to get x isolated. So 3x is equal to 12. And then divide by 3. Our other possible solution is 4. So we have 4 and 8 as our two possible solutions. We have to go back to the original problem and check to see if those two solutions actually work. So let's begin by checking to see if 8 is a true solution. So if I substitute in an 8 here, 8 minus 2 will be absolute value of 6, which is going to equal 6. If I substitute an 8 here, 2 times 8 will be 16, and 16 minus 10 will be 6. So I'm going to end up with 6 is equal to 6. That is true. Therefore, 8 is a good solution. We keep that as a solution. Now we have to check to see if 4 is truly a solution. So let me get rid of these calculations. Check to see if 4 is a solution. So to check the 4, I will substitute a 4 here for x and substitute a 4 here for x. So in this absolute value portion, 4 minus 2 is going to give me the absolute value of 2. And on the other side, 2 times 4 will be 8 minus 10. And 8 minus 10 is negative 2. Absolute value of 2 is 2. And 8 minus 10 gives me negative 2. Does 2 truly equal negative 2? When we find out, no, that doesn't truly equal each other, then that means that 4 is not a true solution to this equation. It is a solution that we call extraneous. It's called an extraneous solution. It's a solution we found by doing all the work correctly, but when we checked it, it doesn't actually solve the equation perfectly. So when we write our overall answer, we will say x such that x equals 8 only. 4 is not a solution. So this particular absolute value equation only has one solution, and that is 8. So I hope that this video helps you with our first learning target in this unit. I can solve an absolute value equation. We'll be doing this for a few days, and it's very important that you follow the steps that I gave you in these problems. Step 1, isolate. Step 2, you make 2 problems. Step 3, we solve. Step 4, check. Is it optional to check, or is it required to check? Because we can have extraneous solutions, checking the answers is no longer optional. It is a required step to determine if the solutions that you find are really true. Okay? All right. Good luck, and I'll be seeing you in class.